Assalamualaikum and hi all. So let's continue our lesson on example 11 part B. Given A, which is a 3 by 3 matrix, and B, a 3 by 3 matrix. Find AB and inverse of A, hence solve the following linear equations. Okay, let's start with find the product of AB, and next is find the inverse of A. So AB is equals to 1, 3, negative 9, 5, negative 1, 3, 1, 3, 7, multiplied by 1, 3, 0, 2, negative 1, 3, negative 1, 0, 1. Okay. So we need to write the operation, if you still remember. 1 multiplied by 1 plus 3 multiplied by 2 plus negative 9 multiplied by negative 1. And we are going to do the same steps for the rest of the elements. So let's start with 1 plus 6 plus 9, 5 minus 2 minus 3, 1 plus 6 minus 7. So the second column, 3 minus 3 plus 0, 15 plus 1 plus 0, and 3 minus 3 plus 0. So for the third column, 0 plus 9 minus 9, 0 minus 3 plus 3, and 0 plus 9 plus 7. Okay, next we calculate the values. So here 16, 0, 0, 0, 16, 0, and 0, 0, 16. So let me factorize 16 out. So we have the identity matrix here, and that means AB is actually equals to 16i. So using this relation, we are going to find the inverse of A. AB equals to 16i. So I'm going to multiply both sides with A inverse. So A inverse AB equals to A inverse 16i. So A inverse multiplied by A is equals to I. So IB equals to this one. Let me rearrange it. 16 multiplied by A inverse I. And that means B equals to 16A inverse. And hence A inverse is 1 over 16 multiplied by matrix B. Okay, so let us write the value of matrix B. 1, 3, 0, 2, negative 1, 3, negative 1, 0, and 1. Okay, so the final product, so A inverse will be equals to 1 over 16, 3 over 16, 0, 2 over 16, negative 1 over 16, 3 over 16, negative 1 over 16, 0, and 1 over 16. Okay, so this is our A inverse. So for the hence question, I'm going to write the answer on the next slide. So next is hence solve the following linear equations. So let us write this system of linear equations in AX equals to B form. So 1, 5, 1, 3, negative 1, 3, negative 9, 3, 7. And our unknowns is X, Y, and Z equals to our matrix B, 7, 5, 1. Alright. So if we take a closer look, so our matrix here, the entries is actually from the transpose of matrix A. So if we take a look here, the first row become the first column, second row is the second column, and the third row is the third column. So that means I can label this matrix as A transpose. Okay, so our unknown here is our matrix X, and this matrix here is our matrix B. Okay, so let us rewrite it in this equation. A transpose X equals to B, and we are going to multiply both sides with the inverse of A transpose. So inverse of A transpose multiplied by A transpose multiplied by X equals to the inverse of A transpose multiplied by matrix B. So the inverse of A transpose multiplied by A transpose will be matrix I. So IX equals to the inverse of transpose of A multiplied by B. That means X is A transpose inverse multiplied by B. Okay, so using these properties, where the inverse of A transpose can also be written as the transpose of A inverse. So that means I can rewrite this equation into X equals to the inverse of A transpose A multiplied by B. So X, Y, Z is equals to 1 over 16, 3 over 16, 0, 1 over 8, negative 1 over 16, 3 over 16, negative 1 over 16, 0 and 1 over 16. And our matrix B is 7, 5, 1. Oh, don't forget the transpose here. So let me transpose the matrix first. 1 over 16, 3 over 16, 0, 1 over 8, negative 1 over 16, and 3 over 16, negative 1 over 16, 0, and 1 over 16. And we are going to multiply with matrix 7, 5, 1. Okay, let's do the operation here. So X, Y, Z is equals to 7 over 16 plus 5 over 8 minus 1 over 16, 21 over 16 minus 5 over 16 plus 0, and 0 plus 15 over 16 plus 1 over 16. Now we are going to get these results: 1, 1, 1. So that means X is equals to 1, Y is equals to 1, and Z is equals to 1. So that conclude our answer. So that's it for this video. See you on the next one. Thank you and bye bye.